Okay, we're doing number 6. Okay, so let's see. I better make this. We're going to go about x equal minus 6, so I got to have a lot of room over here. So I'm going to put the axis here. X squared is going to look like this. Ooh, and I'm not going to have enough room if I go that big. Let's make it here. This is 1 and 1. 1, 1, and that's the point 1, 1 on that curve. And x equal y squared, so that's y equals the square root of x, which is a parabola that goes this way. They both go through 1, 1. So we just got this little slice in there. It's going to be really hard to see, so I'm going to enlarge this in a sec here, but we're going to take it around x equal minus 6. 1, 2, 3, 4, 5, 6. I'm spread out pretty far here. 1, 2, 3, 4, 5, 6. So I'm going to take that around that. So that's going to take it clear over here to minus 12, and it's going to be a little piece over here. Way the heck over here at minus 12. Okay? So I needed more room, but you got the idea. So if I'm going to do a disk on this one, it's going to have a hole in it, a really big hole. There's not a whole lot of volume between these two, but it's going to be pi integral big R squared minus little r squared d. Let's see, if I'm going to slice it, the axis rotation is x equal minus 6, so the slice is going to be this way. Its thickness is dy. So now I got to get the radii. So one of the radii, the big one, goes from minus 6 clear out to that curve, which is this one. So it's going to be 6 plus x. And then the inside radius is going to be 6 plus x for the other curve. Now we got to keep these straight. This x comes from that one, and this x comes from that one. And we have to solve for it in terms of y. Oh, by the way, y is going to go from 0 to 1 because that's where they intersect. So I'm going to have pi 0 to 1 of 6 plus x from the first one is going to be the square root of y. Minus 6 plus, in the other one, x is y squared. Okay, this one's not going to be a lot of fun to do. Let's see. Squaring that is going to be 36 minus 12, or plus 12 square root of y, plus square root of y squared, which is just y. Squaring this, it's going to be minus on all of these, and these are all plus, so it's going to be minus 36 minus 12y squared minus y to the 4th dy, and pi integral from 0 to 1. So 36 minus 36, that's nice. And nothing else disappears, so I'm going to have pi. Antiderivative of this is going to be it's going to be 1 over 2 square root of y times 12, so it's going to be 6 over the square root of y, plus, this will be 1/2 y squared. This will be minus 4y to the 3rd, because the 3 goes into 12, makes it 4. And this will be minus 1/5 y to the 5th evaluated from 0 to 1. And 0 causes an issue here. Boy, oh boy, oh boy, boy. Oh, I took the derivative. I got to integrate this. This is y to the 1/2, so increase would be to the 3/2, so it's y to the 3/2 divided by 12 times 2/3, so it's 24 thirds. There we go. So it isn't divided by 0, so we can still do this. 24 thirds is 8. Let's see. Make sure I did that right. 12 times y to the 3/2 times 2/3. So this goes into there, makes 4 times 2 is 8. 8y to the 2/3. Okay, now I finally got it. So if we put in 1, we get pi inside, we get 8 plus 1/2 minus 4 minus 1/5. And then if we put in 0, we get nothing. So that answer is pi parenthesis 8.5 minus 4. I could have done that in my head. Minus 1/5, 0.2. And I get 13.50884. Let's just show you how you can do this without going through all this mess. We could have gotten this also by going to y equals clear. Some of you need to see this, so I'm going to do it. So I had, let's just say I didn't do any of this squaring. I just said parenthesis 6 plus square root of y, but I'll put it in as square root of x, close parenthesis, squared, minus parenthesis 6 plus y squared, x squared, close parenthesis, squared. And then I'm going to go second, calculate, 7. And I want to calculate the area between 0 and 1. So lower 0, upper is 1. And I get this for this part, I get 4.30000571. And then if I take that, 4.30000571 times pi, I get the 13.509 instead of 884. So this is more accurate than that one is. This is approximation, but we're matching up. Okay, so now let's do it with the ring method. I keep doing the ring method on you, don't I? So this looks like a piece like this, and it goes way over there, and the ring, since the axis is this way, the slice would be this way. So the slice would be, the thickness would be dx, because its thickness is this way. It's going to go clear around and come back like that. Its height would be this. So if I'm doing the ring method, integral 2 pi RH dx. and the x is going to go from 0 to 1. The r, the radius, is going to be 6 plus x. Well, that's good because that's in x. The height will be this, which is the y to there taken away from the y to this one. The y to this one is the square root of y. It's x equal y squared, and the height on this one is x squared. So the y is the height. So the height on the bigger height is y, which is the square root of x, minus the height of the lower one, which is x squared. Okay? So, again, not really pretty, but not bad. So we got 2 pi, integral from 0 to 1. We've got to multiply these, so that's going to be 6 times the square root of x minus 6x squared plus x square root of x minus x to the third dx. And so that'll be 2 pi. This is x to the 1/2, so integrating that, go to the 3/2 times 2/3, so it's 6 times 2/3 x to the 3/2 minus, so it goes to the 3, so it's going to be 6 divided by 3, or 2x to the third. This is x to the 3/2, 1 and 1/2, 3/2, so it's going to be plus x to the 5/2 times 2/5 minus x to the 4th times 1/4. Evaluate from 0 to 1. The 0 is not going to give me anything, so we're going to get 2 pi. 3 goes to 6 is 2, times 2 is 4, times 1, minus 2, plus 2/5 minus 1/4. 4 minus 2 is 2. 2/5 is plus 0.4. 1/4 is minus 0.25. So this is 2.4 minus 0.25 is 2.15 times 2 pi. Let's see if that comes out to be that 13. So 2 pi parenthesis 2.15, and it turns out to be the same thing. Okay. All right, and I could have just typed this into the calculator and then graph that and then go from 0 to 1 and to take the answer by 2 pi and got this. This integral should have given me 2.15. Okay,